Hi, today we're going to use the Cleverscope Frequency Response Analyser to measure the gain phase performance of a linear technology LTC3589 module. Each power supply on the module includes a feedback path that is used to regulate the output voltage. In each feedback path there is a small value resistor, R32 in our case, of 20 ohms, across which we can inject a signal to measure gain phase. We have fitted a small UFL connector across R32 for injecting the signal. We inject into the UFL using the isolated CS701 signal generator. You cannot use the CS700A. Channel A is used to measure the stimulus which is being injected into the feedback path by being connected to TP2 or injection point 3. Channel B measures the response, which is in fact the power supply unit output. Let's get started on measuring the gain phase response for an LTC3589. We set the analysis type to PSU Gain phase. This is a very wide band voltage regulator, so I've gone for a start frequency of 20 Hz to 1 MHz. We start off with 10 millivolts of signal generator amplitude, and we set an auto amplitude limit of 2 volts. Our response goal is 3 millivolts. The idea is that we get enough SNR at 3 millivolts so we can actually control and measure the loop. Let's go start sweep. Here we are, and we're about to calibrate the loop. This is done by checking through a few frequencies. We've already found out where the output voltage is, so you don't need to do that yourself. It's done because we used auto setup. We have sweep amplitude set to auto, so at the moment it's just sweeping through and finding the gain and phase at particular selected values, and then it'll go back and repeat it, but this time with greater precision. We're going for 20 steps per decade. This allows us to be able to track pretty much any gain phase response curve. Okay, so it's done its calibrate, and now it's having a little think, and then we begin the actual sweep. We see the gain is actually quite high. It's up at about 70 dB so far. And as we do this, this is a pretty high efficiency amplifier with a very wide frequency response, which means it's useful for powering systems such as FPGAs or processors that need a low impedance supply over a good wide frequency range. You can see the gain is high. Just select the gain curve, and we're still at above 50 dB at a kilohertz or so, which is pretty good. You'll notice that the frequency resolution was 2 Hz. It was automatically increased to allow for the low SNR. The low SNR signal to noise ratio occurs because we have so much gain, we have very little signal to play with. And as we get more signal, we can increase speed. So there we are, we're done. It still has significant gain up here at 1 MHz. We can find out the gain in phase margins by clicking the FRA dB button, and we see the response up here. The phase margin is 53 degrees, which is good. That means it's got an optimally damped system, and at a very quite high frequency at 121 kilohertz. So that means that below 121 kilohertz we've got gain, and so the bandwidth of this switch mode power supply controller is very good. The gain margin is nearly minus 19 dB at 460 kilohertz. So we're doing pretty well. This is a good controller. Well, thanks for watching. This is how you do it, and all you need to do is press start sweep. Bye.